Okay, in number one, so the first thing I always do is I draw the principal plane. And then ray 1 comes in to the plane, goes away from the focus. Ray 2, I'm a centimeter above, so it's a centimeter below. So I measured up 1 centimeter, so I measured down 1 centimeter here, and I got where this guy. So these two rays are diverging, so they're never going to meet. So I'm going to trace them backwards. So right here. So there's my image. So the focal length is positive because it's concave, the image height is positive because it's upright, and the image distance is negative because it's virtual. The next one, number 2. Start with my principal plane. First ray comes in, goes away from the focus. Second ray, up 1 centimeter, down 1 centimeter. There, like this. So then I trace it backwards. Right there. The focal length here is negative. The image height is positive because it's upright again. The image distance is negative because it's also virtual. Number 3. It comes in, it bounces off the focus. I measure 1 centimeter above, it's 1 centimeter below. So this guy should be right there. There's my image, I. So the focal length positive, image height negative because it's upside down. Image distance is positive as well because it's a real image. Like that. Number 4. So I measure 1 centimeter up, 1 centimeter down. So these are I gotta trace them backwards. My image. So the focal length here is negative, the image height is positive, the image distance is negative because it's virtual. It is a virtual upright. Number 5. Principal plane. So these look very much parallel, so I could like extend them either way and they're never going to intersect. So the focal length, there's no image here. So the focal length is still positive. The image height infinity, Image distance, infinity, it's neither real or virtual, and neither is it upright or inverted. And so on. So this is number 6. This is a long one. So it's out here. Through the focus, comes in, bounces off, the image is right there. The focal length here is positive. The image height, it's upside down. It's a real image, so it's positive, like that. Number 7, again I start with the principal plane. Always draw your line to the principal plane through the focus, and then I'll go to the middle and then up 1 centimeter, down 1 centimeter. So this I'm going to have to trace backwards. My image is right there. So the focal length here, positive. Image height, positive because it's upright. Image distance, negative because it's virtual. Then it looks like we're getting closer still to our mirror. Come in through the focus. Go here, so I'm 1 centimeter above, 1 centimeter below. So these guys are diverging as well, so I just chase them backwards. So my image is right there. So the focal length here, still positive. Image height, positive. Image distance, negative. Virtual, upright. And then the last one, number 9. I'll start out with the principal plane. Draw this from my focus. Then I'll go to my focus, measure up, measure down here. I'm going to have to chase it backwards because the rays don't ever meet, so I'll chase this one backwards. My image is right here. So focal length negative, image height positive, image distance negative, virtual upright. Okay, tell me about the image if you stand on the focus of a concave mirror. That's with respect to number 5. That's referring to number 5. When you're standing on it, there's no image. Those rays that reflect neither come together nor go apart, they're parallel. 15, what happens to the height of the image as you get closer and closer to a concave mirror from the focus? So that's actually referring to like number 7 and number 8 here. Number 7, you're okay, but you get an upright large image, and then you get the image starts, and you could be right on top and you're going to get the same size. So what happens to the height? The height of the image gets closer to the height of the object. It gets closer to it, but it will never actually reach the height of the object. And number 16, what happens as you get farther and farther away from a convex mirror. So here's one, a convex mirror. Let's see where a couple other convex ones are. So okay, so let's look at number 2. 2 I'm pretty close, so I get an upright small image. And then 4 I'm farther away, so it looks like my image is getting smaller. My image is getting smaller and smaller. Image gets smaller and smaller. Is there a place where you can put it in front of a convex mirror to get a real image? No. Is there a place you can put it in front of a concave to get a real image? So you can't put it close because then you get a virtual image like in number 8 and number 7. But if you're far enough away, like number 3, like on the center of curvature, it looks like anywhere past the focus. So anywhere past focus. You'll get a real image.